What's up, Summit Skyhawks? This is Mr. Zoyas, ready with the next Algebra 2 video. Today, we'll be talking about math, because math is the language of the universe of which everyone speaks.
Hey,
What?
what are you doing?
Oh, no, I can't get caught.
This is my video.
No, I can't get caught. This is my next gig. Edmundo Burger out. Anyways, as I was saying, this is definitely the real Mr. Zoyas, as you can see, an official Z-Buck. Now, oh no, definitely real Mr. Zoyas out.
Get out of here. You signed up for two. Go find your own YouTube channel.
What's up, guys? I'm sorry about that. Hello and welcome. So this is the real Mr. Zoyas. Rest assured, those are the imaginary Mr. Zoyases. They're in the other dimension. Welcome, guys. So let's go ahead. What math? Okay. I guess it's true. We are going to be talking about math, but we're definitely going to be talking more specifically about this. So let's go ahead and pull up our actual notes for today. Okay, so our real topic for today, more specifically than math, is going to be factoring, and ultimately factoring by grouping. And we're going to see how, first we're going to learn how to find solutions of factored quadratic equations, and then we are going to learn how to factor quadratic equations. The method we're going to use for this is factor by grouping. But of course we see that's the second thing down here. So quadratic equation. So let's first clarify a few things. What is a factor? Right? Think about that. What is a factor? I want you to come up with an answer in your head. And your answer should be a number which can be multiplied to a larger number. Okay? So an example. 2 times 2 is a factor of 4. Because 2 times 2 equals 4. Likewise, 7 is a factor of 28, because 7 can be multiplied by something to equal 28. And more specifically, 7 can be multiplied by a whole number to equal 28. Right? Factors revolve around whole numbers, or integers, and involve being divisible by a certain number, or aka being able to be multiplied into a certain number. Okay, so let's keep that in the back of our head, and that's going to be cornerstone. A lot of concepts are going to be based on that. So quadratic equations can also be expressed in factored form. Right? So factored form, let's try and imagine what this might look like. It's going to be in a quadratic equation, except written as the product of two polynomials. Right? Keyword product. Right? So we're going to have polynomials multiplied together to constitute a quadratic equation. Such as, and now this is just a very general form that they can equal. So we can have y equals a1 times x plus b quantity times a2 times x plus b quantity. Okay, and now that's a lot of stuff going on in there, but basically what that just means is that we have a number, some number potentially multiplying x, and another number adding to x. Right, and either of these could be positive or negative. We don't know. This is a very general form. Likewise, we also have another number multiplying x and another number adding to x. Likewise, either could be positive or negative, but that's not entirely the main thing we want to take away from this. What we want to take away is the parentheses in between it, which are going to imply that these two terms multiply together. When two terms multiply together, when two polynomials multiply together, we consider that the factored form. Okay? Right, where a sub 1, b sub 1, a sub 2, b sub 2. Side note, that's how you say that. A sub 1 just means a subscript 1. A sub b, b subscript 1. A sub 2, a subscript 2. So on and so forth, are real numbers. Right, and real numbers just means that they exist. They're not our imaginary numbers. Well, sorry, not exist. Imaginary numbers exist, but they are real numbers. There's nothing imaginary about this, right? Staying in our nice one-dimensional line of numbers. So when finding the solution, right? Remember, solution is when y equals 0, right? That's what it is. It's understood that zeroing out either polynomial will multiply the entire expression to 0. So let's go ahead and think about that, right? And go back to our fundamentals of multiplying. So what is anything multiplied by 0? Right? It's 0. So anything multiplied by 0 is 0. Thus, we have two polynomials multiplying together, right? If I can get either one of these zeroed out, right, meaning one of them goes to 0, I have a 0 that's multiplying the other one. What's 0 times anything? Right? It's going to bring it to 0 and bring the whole thing to equal 0. Right? Because that's ultimately what we're looking for, is when y equals 0. Okay? Right? So that's what we mean when we say it's understood that zeroing out either polynomial will multiply the entire expression to 0. Okay? So we're going to be, ultimately, taking a quick peek ahead, we're going to be looking to zero out both of these terms to find our solutions. Thus, solutions to a quadratic in factored form, right? Factored form is the key to this. We can't do this if they're not being multiplied, otherwise we can't take advantage of this. The solutions, right? So when y equals 0, the solutions to a quadratic in factored form are values that zero out any of its factors. Okay, so that's the name of the game here. We are going to be zeroing out some factors. So let's go ahead and take a look at this. So our question is going to be, what zeroes this out? Right? And now this may be really straightforward. This may just hit you. You may just say, oh, x equals 3, or sorry, x equals negative 3. Right? But if it totally doesn't just hit you over the head, what you can do, you can write 0 equals x plus 3. Because we realize that if we can get this whole thing to go to 0, what's going to happen to it? Right? If we can get this whole thing to go to 0, everything goes to 0. Remember, looking for the solutions means when y equals 0, and thus we're trying to find numbers that we can put into this equation above that are going to bring it down to 0. Right? And so from here we conclude that, okay, well I know that x plus 3 is going to have to equal 0 to find my solution. And likewise, I can also conclude that 0 equal to 2x minus 1 will also zero out that term and thus give me a solution. Right? Give me a solution to the equation when it's equal to 0. Right? 0 is playing such a big role in here. Realize, it's the 0 that makes this work, and it's the multiplication that makes this work. Right? Without it, we could not do either of these. Right? Anything multiplied by 0 goes to 0, and we're trying to get it to 0. It's these two things that make this work. So now let's go ahead, and we have two really simple equations if we want to think about it like this. Right? If we want to go through and manually solve these, a little bit more analytical about it, we see that, like we intuitively understood, x is going to need to equal negative 3. And likewise, for something like this, something maybe a little bit less intuitive, we can then also see what x is going to need to equal. So, side note, I'm just going through the algebra on this. I assume you guys are able to keep up with this. This is very simple, right? We just subtracted 3 from both sides to take care of that 3. And right here, we're adding 1 to both sides to take care of that 1, and then dividing by 2 on both sides to take care of the multiplication of 2. So, we then have 1/2 equals x. Okay, and indeed, if we plug in 1/2 to that, let's check that out. So, 1/2 times 2, right? So 2 times 1/2, what's that? That's 1. 1 minus 1 is going to be 0. So 0 times anything, right? This is now 0. What's 0 times anything? It's equal to 0. Okay, so plugging in 1/2 zeroes out this term, consequently zeroes out everything, which makes it equal to 0. Zeros. Whoa, man. Making our lesson work. Alright, let's go ahead and do this one too. So again, right, the question we're trying to solve is what does x equal when it's set equal to 0, right? What's the solution? What's the roots? What are the x-intercepts? What are the zeros? Right? So again, notice we have multiplication going on here. And if we really want, we can think of it kind of like this. With this binomial, or sorry, not binomial, with this square expanded. Yeah, this squared binomial expanded. Okay? right? And then we realize, holy smokes, they're being multiplied. So if I can get any one of these to 0, the whole thing's going to collapse to 0, right? If you can remember way back, I know this is a huge callback, but remember when I made that kind of like little symbol, like the square symbol, and I called it like smush or squash, I think, yeah, squash. When you put it over a number, it times it by 0 and brings it to 0. Think about it like this. We're just trying to find what's going to squash this whole equation. Right? We're looking for numbers that can squash either one of these terms, and then therefore squash all these other things. Okay, so let's go ahead and find that. So again, we realized we can get this to 0, the whole thing goes to 0, so we're going to look for when 0 equals 2x minus 4. Add 4 to both sides, and equals 2x divided by 2, so 2 equals x, right there. Sorry, it's a little bit sloppy. Okay, and that is one of our factors. All right. Now, right, we have two expressions going on here, and maybe you're a smart cat, and maybe you already see what's about to come up. But I'm going to walk blindly into it. We're going to kind of see as we go on what's going to happen. So we have this other factor that we haven't done yet, and we know that if we can get this one to equal 0, well, that gets everything to multiply to 0. So I'll go ahead and set up the equation for this one. 0 equals 2x minus 4, and that's when I start having déjà vu, right? Déjà vu is actually French for to see again, right? My memory starts sticking and saying, wait, didn't I just solve this? I have that same equation right here. I know what the answer is. I know that 2 is going to equal x. So what do we notice about that? How many unique solutions do we have to this? Keyword unique, right? What is unique? Only one. Number 1, right? Just one. We have only one unique solution to this. Okay. Side note, I actually, very, very, very small caveat, way beyond this course, I actually think there is another solution. Remember, for every power we have, we're going to have at least a solution for that. So this is a power of 2. We should have a 2 solutions to this. So I think there may be an imaginary solution embedded somewhere in here. But like I said, for the sake of this course, we're not going that deep. Right now we're just looking and we're saying this has one solution. Okay. Alright. Very last one. So again, we recognize this multiplication of polynomials. We have a monomial, M-O-N-O, right? Monomial. So one number, one term, multiplying a binomial. Binomial, 2 terms. Right, so we want to take advantage of this multiplication, looking for the roots of this. Remember, roots are when y equals 0. Just a way of saying it. And now we're wondering what's going to get either of these terms to equal 0. Okay. Now, being analytical about it, I realize this is one of my terms, the 4x. So I'm looking for what can x equal when 4x is equal to 0. And that's actually quite simple, right? We just divide by 4. And we see that x is equal to 0, and you may have even been able just to look at that and say it, right? 0 times 4, well, I know if I just plug in 0 there, everything multiplies to 0. Right? If you realize that, great. But if you like the analytical way, you like being methodical about it, you can still have your methodical way. You can have whatever you like. Okay, enough of that. So, now for the other term, if we zero this out, we can then go ahead and have everything multiplied to 0. So again, we're going to say 0 equals 6x minus 3. Solving our equation, plus 3 on both sides. 3 equals 6x divided by 6, because now we have a 6 there that's multiplying, so we get rid of that. And we have x going over here. We have x equals 1/2. Just like that. Boom. Get some. Okay, 2 solutions. X equals 0 and x equals 1/2. Don't believe me? Go ahead and plug them back in. Watch how they collapse the whole thing to 0. Okay? So that's the basis for this. Understand, we can get factors for this. We can find the solutions. Right? We can get factors for this. We can find the solution. Right? So now the goal is how do we take it from standard form, like this, and get it into a factored form, something like this. Okay, now big disclaimer, really big disclaimer. So, side note, what we're doing, factoring by grouping, but big disclaimer, everything between here and here, it's going to be very dense. It's going to be a lot of technical math terms. Might feel a little jargony. I promise it's not. I distilled it as much as I could. But understand it's a lot easier to do than to explain. But this might be how a textbook would explain it, so it's also healthy to see it like this. So let's go ahead and read this. I'm going to break it down as we go. We're going to take several pauses because there's a lot of math text in here, right? We normally don't write math in English, we write it in math. Okay, so let's go ahead and just look at this. So quadratic equations expressed in standard form, right? Remember, this is standard form. That's our standard form, so we want to get it like that. Can frequently be factored using the grouping method, right? Factor by grouping. We can use the grouping method to factor these, to turn these into two polynomials multiplied together. Let's call these numbers D and E. So we're just calling the numbers. Oh, my bad. So very first step, right? So we have our equation in standard form. We want to multiply A times C. Right, we want to multiply A times C, and we want to find factors of that. So find factors of A times C, whatever that number is, that are going to add to B. Right? This is kind of the fun part of it, to be honest. These problems right here, some of you guys are going to struggle, and that's okay. That's how you get better, right? You struggle. You ride the struggle bus for a little while, and then the bus driver kicks you off because he realizes you're homeless and you're asking too many people for money. And when that happens, you get stronger, right? You ride the struggle bus for a little bit, and you get stronger, right? That hard stuff, right? Remember, you want an easy life, do hard things. You want an easy grade, do hard math, right? So even if you struggle, that's okay, but for those of you who aren't going to struggle, you're going to realize this is a puzzle. It's actually a very fun puzzle because we're going to have to find factors of A times C which add to B. Once we find that unlocks this problem. That allows us to then factor this. Okay. And also, one more quick tidbit. If this is difficult for you, it's probably because your factoring abilities aren't up to par. I suggest reviewing factoring. And review factoring of real numbers, not variables. First real numbers, then go to variables. Okay, a lot of factoring in here. Okay, so whatever these numbers are, right? We're looking for factors of A times C, right? So A times C that are going to add to equal B. That's the name of the game. We're going to call whatever those numbers are D and E. So this is our premise, right? D and E need to equal A times C, right? Because D and E are also factors of A times C. So whatever A times C multiplies to B, so should D times E. And D plus E is going to equal B, right? So our factors should add to equal that middle term B. Then once we find B, then we're going to use that to rewrite the term bx as dx plus ex. Because remember, d plus e add to be b. So we can say that bx equals dx plus ex, right? And just think about this for a second. That's like saying, imagine that b is 100, and then d is 101, and e is negative 1, right? 101 plus negative 1 are going to equal 100. It's not that mind-blowing, right? But it's going to allow us to do some really cool stuff. So, rewrite them as dx plus ex in your original equation, y equals ax squared plus dx plus ex plus c. Right? We want to rewrite it like that, replacing bx with dx plus ex. Or y equals quantity ax squared plus dx plus ex plus c quantity. Okay, and all I did between these two was just put parentheses, right? Between here and here, just put parentheses around here because we want to think about these two groups right here. Some special stuff is going to happen. And actually, I call it magic. It's really kind of crazy how this method just works all the time. There's even an abbreviation for it called magic method that can help you remember the steps. I'll give that to you guys to help you remember the steps as well. So now factor out common multiples from both terms. Our terms here, ax squared plus dx and ex plus c. So these two terms, we're looking for things to factor out. Once both terms are completely factored, right? Once they're completely factored, no more stuff to take out of them, no more multiples, you should have something of the variation y equals p times x times quantity nx plus m plus q quantity nx plus m. Now realize this is all just saying p is a number, q is a number, n is a number, m is a number, and then m, n, and m, right, they're going to match right there. And then p and q, they don't have to match. They're just going to be some other number. But the key thing, right there, these two things. I'm going to go ahead and box this because this is the key point. When we factor it, once we factor them completely, how we know we did it all the way through, so when we have those two terms equal to each other. If those two terms don't equal to each other, you got more stuff to factor out, right? Once those two equal each other, you know you're good. You factored everything out. So this can now be factored to be, now think about this, and this is the really crazy part, right? So now both of these have a factor of nx plus m. Right? They're both multiplied by the same term, so what does that mean? They both have factors of it, aka we can factor it out. We factor out the nx plus m. And what does that leave behind? That leaves behind their coefficients. The px plus the q. Right? So the px plus q having our nx plus m factored out. And just like that, we are home. Right? Very rough travels. Right? Oh god. Man, I call myself a Star Wars nerd. I can't even think of the Millennium Falcon, right? Millennium Falcon, right? We just went light speed. We had a very rocky light speed, and we had a very tough travel through the galaxy, but we did it, right? We made it out to the other side with what we're looking for. Our two factors, because then, once we got the factors, we can find the solutions. That's not hard, right? We did that up here. So when we take this skill, and after we factor by grouping, we then do this. So let's go ahead and factor by grouping. Woo! I am pumped. This is actually great material, great brain exercise. You want to talk about how to make your brain better? Factor by grouping. You're in a boring meeting? Do some factoring by grouping. Right? You're in a boring class. Do some factoring by grouping. Make yourself smarter. I like to think of these as like mini games of chess, just like mini puzzles. Right? Make yourself smarter. And realize you get smarter by doing stuff like this. Okay, so remember, side note, those two things that were equal, that's what makes the magic happen. Right, and that's all it's saying there. Both terms had this, so we could then factor it out. So, factor by grouping, we're going to go through the steps. Find factors of a times c, which add to equal b. So, I'm going to teach you guys not initialism, but a acronym, right? Initialism is when you say the actual initials. If I said MAG, IC, that's what I would call that. But this is actually an acronym, so I say the magic, right? My magic method is going to help me remember my steps. So my first step is I want to multiply A times C. Okay, so let's go ahead and label them so we know what we're working with. A times C is 2 times negative 3. That's going to be negative 6. Okay? Right? That equals A times C. Now we're going to look for numbers for factors of A times C that are going to add to be 5. So I'm going to write 5 equals, and now I'm going to look for factors of negative 6 that will add to be 5. Okay? So now what I want to do is I just want to list some factors of negative 6 to see what I can get. So first I'm going to write 1 and negative 6. And let's go through and check these as we go. So what's 1 plus negative 6? It's negative 5. Ooh, I'm close. I'm close, right? I need a positive 5. So what if I switch the signs, right? Negative 1 times 6, that equals negative 6. 6 minus 1 equals 5. I got it. 6 minus 1. Okay, these are my two special numbers. So now what we're going to do is we're going to group. We're going to use 6 minus 1 to group together our b term in our equation. So writing our whole equation, because remember, we're just changing the way that we group the inside stuff on here. 2x squared plus 6x, minus x minus 3. Okay. Right? So we're going to split up that b term, and now we're going to group our terms together. So I want all these terms grouped together, and all these terms grouped together. Right? My first two and my last two. Side note, they're not multiplying, they're adding. I know it's easy to make it look like they're adding, or multiplying, but they're actually adding. I just want to make sure I include my negative with my x. If I don't include the negative in there, it's going to mess it up. I'm not going to be able to get these two to match. I'm not going to be able to get my final answer. Okay? Now I want to factor this. Right? So y equals. Now what I want to ask, what can I factor out of each term? So what can I factor out of this? Okay? So let me scratch that out. That's a mess up. Right, so what can I factor out of this? What do they both have in common as far as multiple goes? Well, this is x squared, this is x, so I can factor out an x. What else can I factor out? I have a 2 and a 6. What do those have a common factor of? 2. So I can factor out a 2, leaving me with x plus 3. Ooh, I'm getting excited. Getting excited, right? I already see some matching going on. I see some close matching. What factors does this now have in common? Right? What factors does it now have in common? I can pull out a -1 to factor out a -1 out of there. And look at that. That's going to make the magic happen. That's why we call it magic. I swear, it really is magic. It truly amazes me. I'm actually, sometimes, like, I'm trying to find a proof for why this works, because I'm very intrigued by it. Now, these two match, so that tells me I did it right. And let's go ahead and compare that form to up here, right? We have our nx plus m, right? N would be 1, x plus m would be 3, and they match. So now we can factor out these two things because they're both multiples of each term, right? It's absolutely crazy. So we write x plus 3 right there, and then 2x minus 1, right? 2x minus 1 right there. And we have just successfully factored by grouping. Okay? Now, go ahead. We're going to find the solutions, so I'm going to speed a little bit through this. I'm just looking for what's going to zero out either of these terms. And doing this in my head, you can check it if you want. Maybe pause it and work it out yourself. -3 is going to zero this out, and 1/2 is going to zero this out. Okay? I'm telling you, man, the skills in this, the exercise of it, the puzzle of it, so healthy. Just so healthy. Okay? Oh, and I guess let me go ahead and just write one more thing. Right, of course, we know that's what our factors are because we're looking for 0 equals 2x minus 1 times x plus 3. Okay? Shaboom. Next one. Okay? So, we're going to factor by grouping again. Okay? Now realize this is kind of like our y. Right? I know it's a and z, but think about it. What's the input here? What's the output? That's our output. Right? So we have 0 equals that. Minus 9 z squared plus 3z plus 2. Okay? Now let's go ahead and use the magic method again. Now I'm actually not going to do my work next to the magic method just because I think it can get a little bit crowded over there, but I think it's a good acronym to remind you the steps to go in and what you're looking for. So first you're looking for a times c, and what's a times c going to equal? Well, this is a, this is b, this is c, and so a is going to be -9, so -9 times c, which is 2, which is going to equal -18. Sorry, kind of running into it there. Poor planning. What do you know? Mr. Z's a poor planner. Who would have guessed that? That's really terrible. I should probably edit that out. I don't know how to edit. F it, we're going live. We're keeping it live. So now we're looking for the two things that are going to add to b. Okay, what's going to add to b? So, right? So, looking for the two factors of -18 that will add to b. b is going to equal 3. So let's go ahead and I'll do my factors over here. looking for factors of negative 18. Okay, that's what a times c multiplied to, so looking for factors of negative 18. Now, what are my factors? I'm going to just go ahead and look for some factors. And side note, as you get better at this, you're just going to pick the factors out immediately, right? I actually already know them in my brain, but I'm pretending I don't know them for the sake of this video, right? For having that authentic experience. But let's go ahead. What can 18 be divided by? I don't know. How about 9 and 2? Right? 9 times 2 is equal to 18. So I'll do negative 9 times 2 is equal to negative 18, right? That works, okay? So now what's 2 plus negative 9? It's negative 7, doesn't match my b. Okay, next one. What else can I break this down into? Well, I can divide 18 by 6, so what if I do like negative 6, and then times 3, right? 3 times negative 6, that negative 18. So what's 3 times negative 6? It's negative 3. Ooh, I'm close, right? Let me go ahead and switch those signs. So now I'm going to have a negative 3, a positive 6, right? So 6 minus 3, sweet. We're rocking and rolling. Alright? Ooh. Earthquakes in Texas, who knew? Just kidding, I hit my desk. Okay, so now we're going to look to group our middle term into 6 minus 3, right? We want to turn 3 into 6 minus 3, because remember, that's the same thing. 3 is equal to 6 minus 3, so that's okay to do, right? Nothing is really changing. Let me draw some dots to keep it organized and keep it separated. So minus 9z squared, and then plus 6z minus 3z's plus 2. Okay? Now I'm going to look for the factors of either of these. Okay, so I'm going to look for factors in negative 9z squared plus 6z, and then plus a negative 3z plus 2. Okay? So now, what can I factor out? Okay, well, what can I factor out of this one? What do they have in common? Well, they do have a z in common, so we'll go ahead and factor that out. They have a z in common, and what else do they have in common? Right, 9 and 6, they have a factor of 3, so we'll go ahead and pull out a 3. So negative 9 divided by 3 is going to be equal to, number crunch, that took longer than it should have. That's what happens when you get old. Negative 3 times z plus 2. And oh snap, look at that. It already matches, right? I already have my common factors that are ready to be pulled out. Okay, so let's go ahead and pull out our factor of negative 3z plus 2. So negative 3z plus 2. And then what's left behind? What are the numbers in front that are being added? Well, we have 3z plus, oh, we don't have anything over here. So what would that number be? Right, when we don't have anything in front of our coefficient, that would just be 1. Cool, so 3z plus 1, and that's, ugh, poor planning again. Plan better. These are kind of intense problems. There's a lot of work for them. So 0 is equal to that, right? 0 is equal to 3z plus 1 times quantity negative 3z plus 2. Alright, now, again, you go ahead and do the actual work to find out what the factors are. But for this, our factors of z are going to be negative 1/3 and also 2/3. Okay? Right, I can do that in my head. Done this a lot. Lots of practice. It's easy for me because I put that work in. You will get the same results too if you put that work in. But understand, just for the sake of room and focusing just on the skill, I'm only going to tell you what the solutions are. I'm not going to show it right here. You want to see that? Click back in the video, rewind. Next problem. Okay? So now, factoring by grouping, right? So let's go ahead. We're doing the magic. And dude, this stuff really is magic. It's crazy how it works out like this, and I truly invite you to ponder why it works like this. I will just give you an A in the course if you can find a proof to it before I can. Just putting that out there. An A for this semester, I guess. Oh no, yeah, let's do the whole course. If you can find a proof before I do, I'll give you an A for the quarter, and then we're gonna get your, A for the year, and then we're gonna put you on like the fast track for like collegiate math, because you are gonna have a great career if that's the case. So okay, let's go ahead and look at this. So now this one's a little bit tricky, right? We don't see a middle term, do we? Right? So what does that mean our middle term is? Right, we have A right there. Now is this B or is it C? I don't know. Let's go ahead and look at our standard form. C doesn't have a variable on it. So then this one would be C because it doesn't have a variable on it. So this is C. Now what does that mean B is? Well, B's nothing, right? B is like our X, who did things that are unmentionable, and we don't talk about them anymore, right? They're nothing, right? B is nothing added to here, so B is 0, right? B's not there, so B is 0. Okay, so now let's go ahead, right? We're going to multiply A times C. A times C, well, that's just going to be negative 36, right? 9 times 4. Negative 4, and actually let me go ahead and write that out just to kind of show you what's going on, right? 9 times 4 equals negative 36. Right, now we're going to look for things that add to B. What does B equal? B equals 0. So we want to find things that add to B. Weird, but okay. Well, I trust it, right? Still the same game. We're just going to look for factors of negative 36 that are going to add to 0. Right? And what could that possibly be? So think about it. If we're adding to 0, I want two numbers that are the opposite of each other. So that means they have to be the same but different signs. What could that be of 36? I know. Negative 6 and 6. Right? Negative 6 times 6 is equal to negative 36. 6 plus negative 6 is indeed 0. So that's what we're going to break this up into. Okay, so now over here we're going to write Q, which, by the way, Q is 0, right? We're looking for the solution, so we set that equal to 0, is equal to 9u squared, and then plus 6u minus 6u. And right, and as weird as that is to say, realize that makes sense, right? Because 6 minus 6 is just 0, and we had 0 there to start with, so that's okay. So, minus 4. There we go. Let's start the factoring. So we're going to group this up. 9u squared plus 6u, quantity, plus quantity negative 6u minus 4. Okay, so what are my factors in here? Well, I have a 9 and a 6, that shares a factor of 3, so let me go ahead and pull out a 3. And let me also pull out a u, that's my bad. So we pull out a 3u, because those are both factors in here, right? 3 can divide 9 and 6, and u can divide u squared and u. So we have u, talking to u, plus 2. Right? Now over here, we have negative 6u minus 4. So we're looking for factors that we can pull out. What are factors of negative 6 and negative 4? I know negative 2. Right? Negative 6 divided by negative 2 is 3. And then negative 4 divided by negative 2 is plus 2. Ruh-roh. Hold on. What did I do here? Oh, I see. Oh man, you guys you thought you were gonna get it too, didn't you? You so thought you were gonna get it. Right? And that's the great thing about it, right? So I forgot to write a 3 right there, right? Because 3 times 3 is 9. Right? And that's the great thing about this. You can't move forward if you made a mistake. If these things don't equal each other, right? 3u plus 2 and 3u plus 2, you can't move forward. You need these two to equal each other, right? It's mistake proof. It's Mr. Zoya's proof. Because let's be honest, I make a lot of mistakes. It's okay, but mistakes are all right? Otherwise, I wouldn't be here. Huh? No, but okay, math. So now we have a 3u plus 2 in common. So we can go ahead and factor out a 3u plus 2, right? Because they're both multiplied by that. And what are we left over with? We're left over with 3u plus negative 2. Or 3u minus 2. Just like that. And that is how the cookie crumbles. Okay, remember that's all equal to 0, just going back and putting that in. Now you can go ahead, right? You can go ahead and find out what u equal, right? Do some self-reflection, find out who you are, and when you do that, you're going to realize that you are 2/3, and you are also negative 2/3. Right? That's where self-reflection is going to get you. So when you solve for your solutions, u equals 2 divided by 3 and negative 2 over 3. Last one. Home stretch, final stretch. Quite a long video, but remember, think about all the examples we did. Right? 7 examples is quite a bit. It's not bad, especially for a pretty intense new method like this. So okay, remember we're solving for the solution, and the solution is when y is equal to 0. We know y is our output, so we have 0 plus 3 equals 2x squared minus x minus 4. Now, what's different about this? What is not in line about this? It's not in standard form. Okay, notice, sorry that was gross, when not in standard form, hopefully the mic didn't pick that up, when not in standard form, it's not equal to 0. When it's not equal to 0, we can't have this factoring magic, right? We can't have this multiplying to 0 stuff going on. Alright? So, what we're going to want to do is we're going to want to bring the 3 over to the other side. Oh, my bad, guys. That's actually supposed to be, I just realized this is a typo in the document. That's actually supposed to be minus 3. If this is going to work out, that needs to be a minus 3 up there. So 0 minus 3. So we're going to add 3 to both sides. Okay. Typo in the document, please make sure you fix that. Otherwise, you cannot factor it. Realize not everything is able to be done with factoring by grouping. There are some anomalies. And for those anomalies, we will use another beautiful method called square method. Finding the square. And you guys are going to, it's going to be your frenemy, right? You are going to love and hate it. You're going to hate it because it's hard, but you're going to love it because, God, it's going to make you good. So, okay, right? So, small fix, that need to be a minus 3, so we add 3 to both sides. We now have 0 equals 2x squared minus x minus 1. Okay, and how do you know if factor by grouping doesn't work? We'll talk about that later, but the main way is if you can't find factors that are going to add up to b, you can't do factoring by grouping. So if you make it to this part, right, if this works, you know you're good to go, right? These next steps are affirmative. We are all ready for launch and missiles on. So let's go ahead, right, we're doing the magic method again, just to remind us of the steps that we're going in. So multiply a times c and then add to b. And so just a times c, 2, well in this case, sorry. Remember, these are my a's and b's, a, b, c. 2 times negative 1, negative 2, and b is equal to negative 1. Okay, so I'm going to make these factors, and this might be an easy one. So what are the factors of negative 2 that add to negative 1? Gee, I don't know. Is it negative 2 and 1? Indeed it is. Right, so negative 2 plus 1, 0 equals 2x. Now this is where we're going to break up that middle term. And once you do this enough, it's going to flow like this. You're just going to go from one step to another, not even have to think about it. It's going to be muscle memory, and you're going to have these just buff math skills from it. Okay, so grouping it together, so now we have 0 equals 2x squared minus 2x, grouping those together, plus x minus 1, grouping those together. What's our common multiple that we can pull out? Our common factor is 2x. And holy moly, it worked. Some would even say, it's magic. It's magic. Punishment. Right, and holy moly, they equal each other, so we can go ahead and factor out an x minus 1, leaving behind 2x plus 1, right, because we have a 1 in front of there. Boom. Made it home safe, right? We're good to go. Now you can go ahead, I challenge you to find out what the factors are to this, but I'm just going to go ahead and tell you so you can check your work that it's going to be negative 1/2 and 1. Okay? Factor in by grouping. Yay!